everyone, welcome back to this data science series. In this lecture, we are going to cover exploratory data analysis in data science. What exactly is exploratory data analysis or EDA? So, in this, we can think of a hypothesis. Whenever we think of a hypothesis, it is a rule which it is a thing which can be true or false. Clients may have a prior hypothesis which can be either true or false, but to validate it we can use a classical statistical method or categorical values. So let's have a look in these. So let's introduce to EDA. Understanding the data. First step is understanding the data. It helps you to give a comprehensive understanding of what your exactly data set is, with its variables, potential relationships, and then later on it helps us to identify the patterns or the trends in these values. It also cleans and prepare the data and formulate the hypothesis as I said. Now let's have a look in this graph. So in this we can see that 0 to 5000 is a range, then 5000 to 10,000 and so on. In this range we can see the previous outcome column. This is a bar graph. In this non-existent is a graph, a bar of this bar graph. It is the only column which goes from 0 to 20,000 and it can be like evaluated. But what about the graphs of success and failure? Because these are under the range of not only 5000, but it is failure is in 0 to 2500 and success is more less in the range. And we can't have a deeper, a wider idea of what it really is. So this is the graph, a bar graph, but we can draw a normalized bar graph. This is what a normalized bar graph looks like. Here we normalize the range so that we can have a wider, a deeper, a clearer instinct of what the data set is. Pro tip, never use a normalized data bar graph without a bar graph, because it is helping us to understand the bar graph. But without a normal bar graph, we can't have the exact idea of our range of the data set. Now let's know how to construct these bar graphs using Python. Let's have a look. Here we are constructing a bar graph. It is as you know have a rectangular bars as we saw in the presentation. So now we are having this code where we have imported the packages matplotlib.pyplot as plt and numpy as np, because we are going to use these to make our graph. Define the categories, the values, and then we have plotting the bar graph on xplot np.arrange length of categories which we have given, and then width also we give so that we can know what width our each bar takes. Then we have plotted these values and has given them labels as set1 and set2, and then we have plotted on x label categories, on y label values, title is bar graph with overlay, and so on. So let's see the output, and this is the output. This is the bar graph which we got from our code. Next we are gonna cover is how to construct contingency tables using Python. But before that we should know what is contingency table. Contingency table is a cross tabular form in which each cell can have the representation of the relationship between variables, and each variable's relationship with another variable is inside the contingency table. Like each and every variable is associated with each and every another variable. No variables are left without any relation. This is contingency table. So now let's have a look on how these are constructed in Python. This is the code of contingency table. Again imported pandas packages pd. Then we have inside the data our data set. Then we are creating a contingency table using the function crossstep of Panda package. So this is how our table will look like. It will have each data set related to each variable, like each variable of the data set with another variable. It is loading. Till then we can have a look on the code itself, which have the contingency table which we have printed. In contingency table it has used pd.crossstep which have data as gender which we have given and data of preference which is given. So see here we can see preference, coffee, tea and gender. Female who loves coffee are female and coffee relationship, female and tea relationship, male and coffee relationship and male and tea relationship. So every variable is associated with every other variable. Now let's have a look on our another topic, which is histograms. What is histograms? These display the frequencies related to the frequencies. In bar graph we have different bars and there's a separate space, a blank space between each bar graph, each bars. But in histograms those frequencies are depicted, and as you know that frequencies are connected, they are continuous. So histogram is continuous. So let's have a look on how to create histograms in Python. So this is our code to construct a histogram with overlay. It shows the frequency distribution of numeric variable. Overlaying another histogram on line adds content or context. So here we have imported Matplotlib .pyplot, and this is how we have plotted histogram with all those things which we have: dataset, data1 and data2, plt.hist. We are using matplotlib.pyplot library, and this is how our histogram looks like. Nice. Then we are moving on to the next part, which is performing binning based on predictive value using Python. Now what's binning? Binning is uh, we can say binning is a thing in which we bin or group the data set, because sometimes it is not possible or it is not very facilitating to work with numerical data. So we convert it into categorical data. So we have first procedure as binning for prediction, like dividing continuous data into discrete bins based on predictive value for target variable. This can improve the performance of machine learning models. And its example is customer segmentation. Like we have segmented the parts, we have categorized them. So now let's have a look on how it is done in Python. This is the code where we have imported pandas and numpy, have bins as 0, 25, 35 and 50, like under 0, under 25, under 35, under 50 in categories, because we have ages in between, so we can categorize them like childs, adults, elders, and this is how it looks like. Now, how we can visualize the relationships? Relationships can be visualized using scatter plots, and its example is sales versus advertising. We can detect outliers and anomalies. Also, we can assess the data distribution and normality. Now, up to here, we have learned about histograms, bar graphs, and bins. Also, we have learned about contingency table. So this is it for this lecture. Now we will meet again in another lecture where we will learn about data preparation phase to model the data. Till then, stay tuned. Thank you for watching this video.